The different world. All the.
So going into there, what happens? There's one tree.
Okay, we're ready. So why don't we get started? I'll read the first part for part 2 of the preparation assignment.
Okay.
ANOVA, according to William Butler Yeats, she is the Gaelic muse, for she gives inspiration to those she persecutes. The Gaelic poets die young, for she is restless and will not let them remain long on earth. One study designed to investigate this issue examined the age of death for the writers from different cultures and genders. 3 categories of writers examined were the novelists, poets, and nonfiction writers. The ages of death for female writers in this category from North America are given in the Women Poet data. You would like to determine if any of the age of death is different from any of the categories of writers. So use A equals 0.05 as their level of significance.
I have no idea what.
So the first question is, design the study. What is the research question?
So at the end of my
So I put the research question is the mean of the age of death different from any 3 categories of writers?
Right.
That's basically what I put. Yep. Let's see, and then the state the null and the alternative hypothesis is the null is all the means are equal, and the alternative is one or more of the means differs from the others.
Yep.
Good.
So,
Oh, go ahead.
oh, for collecting the data, when it says to describe the data collection, but they didn't really say, they just gathered it for all, they just stated it. They didn't say like we took a survey or they just said here they are.
Yeah, that's true. Like we don't know if that was a random sample or what they did on this on this research.
So we just know
So
that
I just put that.
ages.
Yeah, that's basically what I put.
Okay. I was like, describe the data.
I know. Well, the research looked at this, but it didn't tell us much other than that.
Right.
Okay. We have the describe the data. I usually set up just I set up like a little thing that kind of brings everything together for the data for me. So that I just have it, like I immediately run all the numbers and then I can see where everything is all at once. And so I've got that the test statistics for 1 is 67, for 2 is 32, and then 24. I'm just going to go down. I'm just going to go straight down. So the mean is 71.45, 63.99, 76.99, 88. The standard deviation is 13.052, 17.297, and 14.097. I have totals too, if we needed the totals of all of them. And then I also wrote the upper and lower, but we didn't end up using it for any information for this. And so then I also had written out the means and everything else. And I do have a graph brought up. I did the box plots and the other stuff. This one's really interesting because we have 3 things that we're looking for the means of, and 2 of them fall in the large number samples, and so we know that they're fine. And so we look at the box plot and the QQ plot for 3, and it looks like it's going to be fine. So that's
Good.
the stuff that I have.
That's basically what I have too.
Okay.
Yep.
So number 4, make inferences. What type of hypothesis test is appropriate? And I put ANOVA.
Yep.
Yep.
So we have more than 2 means.
That's right.
Yeah. So what are the requirements for this test? So it needs to be normally distributed, which they are not necessarily. But it looks like, I mean, they're close, like you said, with the QQ pods approximately normally distributed. So,
Yeah.
and the variance for each group. So, let's see, the variance is not 4 times the smallest number, so we assume they are equal.
Yep.
And like you already mentioned, 2 of them were large and the other one wasn't,
But yeah, on the QQ plot, I mean, they have there's a couple of outliers, especially down at the bottom for group 3.
Yeah.
But they stay pretty close.
Yeah.
Yeah.
I mean,
so
I guess
I think
if
it's
you look
okay.
at, yeah, I think so.
For the, are we on C? Right?
Yeah.
So for the F statistics, I got 6.56.
You're up there.
Okay, so,
Yes.
Okay.
Yep. And then see the degrees of freedom, I got 2 and 120.
Yep.
Mm-hmm. Yeah.
And for the p-value, I got 0.0019.
Yes. Wait.
Yeah.
Point.
So would that one be 0.002?
Yeah.
Okay.
Are you rounding
Yeah,
up?
for the p-value.
Okay. Whew.
Yeah.
Because that's what I'll
Ours
put.
doesn't even give us the other. It just says 0.002.
Yeah.
Oh, that's right. That's right. For Excel, it gives the whole
thing.
Yeah. And then that's less than 0.05. So we reject the null.
Yes. We reject the null.
Yeah.
So that means that we have sufficient evidence to say that one or more of the mean ages of the group of writers, or the mean age of deaths of writers, is different.
Yeah.
This
Number
one,
5 was funny.
yeah, like take
I was
action.
like, what do you want me to say?
I know. It's
I
like,
guess.
Encourage writers to eat better or get out more in the sun. I don't know.
right?
Yeah. Or don't let them write poetry if they're depressed, or
Right?
maybe they need to see a mental health therapist or something.
Maybe that's what they need to do. Maybe the next test needs to tell us how they died.
Yeah, that's true.
Because if they died of natural causes, it's like, don't do anything. I guess if you write poetry, you're just going to die early. But it tells us they did something to hurt themselves, then yes, you definitely would have other things that you would recommend.
They all died of like rickets.
Now, if it's all suicide, then they definitely need to
then that's a problem.
therapist or something.
That was funny.
So,
okay.
Anyway, everyone feel comfortable with that then?
Yeah.
Yes.
This one.
How about you, Manette? Are you feeling comfortable? I'm not hearing you.
Yeah. All of them into one place, right?
I think so.
Okay.
Oh, that's right near you guys.
As long as you have 2 walkers.
Awesome.
No, you place them anywhere.
2 walkers. And Daddy, should we, okay, so go make your places?
Let's say it's island right.
So should we start the quiz? Is everyone good with that?
Yeah. Let me just bring it up.
Then I cannot send you. So you
Daddy,
send
you're
them
going
anywhere.
first this time.
Alright, so I'm gonna.
Okay.
Okay. Oh, wait.
There we go. Do we need to open anything?
I opened the ANOVA file in the.
Yeah, I have a Nova open.
Soccer shoes.
Soccer shoes, okay.
It looks like.
Okay. I wish I hadn't erased all that information that we did for the... Okay.
Wait a minute. Okay. Ready to three?
Soccer shoes, soccer shoes.
Ready to number 3?
I want to go into here because this is.
We don't have to input it just yet, huh?
No.
Yeah, I think
I'm
it's
like,
down
wait.
Just erasing everything else so I don't...
Get all confused.
Yeah.
That is wise.
Yeah, that's what I'm trying to do, get everything set up.
One place, yeah.
Yeah.
Trying to remember, did we have to... Was this the one? Yeah, we did have to transform this information, didn't we?
Yeah, we have that.
Yeah, most of the homework and stuff we didn't have to, so.
Yeah.
But it looks like this one we do. Possibly.
Okay.
So, do you want me to start with 3?
Yeah.
In a NOVA hypothesis test, we reject the null when there is sufficient evidence to indicate at least one mean is different from the others. I put true.
Yes.
Yep.
Yes.
So number 4, what requirements need to be checked when performing a NOVA hypothesis test? Let's see. So it would be B and C.
Yep.
Yes.
Patty, it's your turn now. You're in the car. So.
Okay. To check if each group is normally distributed, do the following. Let's see. Construct a scatter plot. I don't even know what a scatter plot is. Construct a histogram of all the data, or construct a QQ plot. So it would be a QQ plot.
Yeah. The 6, we assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the smallest sample mean, or each group has the same sample size.
So the largest variance is less than 4 times the smallest variance.
Is it 4?
Yeah.
Yeah, it's 4.
Yeah, it is 4 times. Yeah.
Why did my brain want to say 2?
Yeah, it's 4.
Yeah. Because didn't they say something at some point where you could take the standard deviation and square it, and then I'd have to go back and do that.
Well, it seems like there was something like that.
Yeah. Yeah. A NOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. A 1, 2, a 1, 3, and a 2, 3. How many pairs are there when there are 4 samples?
Let's see.
Four pairs? No, wait.
Are there 5?
I was going to say, there's
3, 4.
1, 2, 3, 4. There's 3. I think there's 6.
3, 2, 4. And there's
Let's see. So there's 1, 2, 1, 3, and 1, 4. 2, 3, 4.
That's what I thought it was 6.
You have 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and then 3, 4. Is that right?
Yeah.
Yeah. So yeah, it should be 6.
And I just
So
double checked it.
6.
It is 4 times the smallest
Awesome.
variant.
Uh-oh.
I don't know why my brain wanted to say 2.
You just got engaged. You're just thinking everything in pairs. It's all good. Okay.
Okay.
So 7 is
soccer
6.
shoes data has 6 groups: A, B, C, D, E, socks. This data can be found in the wiki. Load all 6 samples into the quantitative inference procedure spreadsheet, or perform an ANOVA test in SPSS. And observe the p-value is 0.0809. Remove the socks data. What is the p-value?
Interesting.
Okay, let me figure what it's saying. So we load it.
Okay, but then you need to remove.
I don't know how to remove it. Do you?
I think we'd have to go in and actually just erase that bottom information for the socks. And then recalculate it.
Okay,
So you would remove everything below 101.
okay.
Okay. I see. So we put it all in and then we remove it?
Well, all the information you guys are copy and pasting, so you can just not paste the stuff for the
In Excel.
yeah.
Okay. Yeah.
So then we need to just go back through and then do the descriptive statistic.
Oh, okay. That's weird. Why do they do it that way?
Right? Okay.
Why not just leave that one off?
I know. I didn't have one like that before. That's confusing me.
I was like, remove the socks data.
Take off your socks and then we can finish the exam.
Right. Okay, I just want to double check what the statistic or what the Q or the p-value was before the yeah.
So 0.809, is that what it said?
You have 8. Is that what it was before?
Mm-hmm.
Yeah, I think that's what it was before.
Okay, so now I have 0.309.
Yes. So do I.
Sorry, I'm still copy and pasting.
Okay, wait. So, did you transform? Did you do transform?
I didn't need to because it's already transformed from the last thing.
Well, that's what I thought. But when I try to do the one-way ANOVA, then it won't let me.
I didn't do a one-way ANOVA. I just went in and I just went straight to analyze and did a new descriptive statistic.
Okay.
Let me just double check it for a new one-way ANOVA. Let's see, so it's recoded. Okay. Okay.
Is it letting you do it?
Yeah, it let me do it, and it's the same thing. It's
okay. How did you?
0.309.
Okay. So how did you do that? Because when one-way ANOVA,
it wouldn't let you do it.
The information or keying accuracy into the dependent list.
I think.
But then it doesn't give.
It doesn't give you anything. I just
it's not letting me.
It's not letting you do it. Okay. I just went right on to the one-way ANOVA, and then I just double-checked the information that I put in. When I did the transform earlier, it transformed everything, and the last numbers for the socks, for me at least, were the number 6. And so by taking that out, it doesn't interrupt the chain. It doesn't. So A is 1, B is 2, C is 3. So taking out 6 didn't affect my data.
But you didn't recode, right?
No, I didn't
Or you
recode.
did?
I recoded as soon as I opened up the page and just got the information ready before we read the question. I recoded all of the information first.
So you recoded with footwear? Is that what you did?
I recoded when the socks was part of the data.
Oh, okay.
So that's when I recoded, and then I just went in and erased the socks as the data, and then I just redid the descriptive statistic and redid the one-way NOVA.
Okay. Let me see. Because I hadn't recoded then, and so I think that was my problem.
Got it.
Again.
Okay.
Searching the car and I got a machete.
Okay. So I start with 8 now.
Really? Why?
My kids have half days for the last 3 days or last 2 days, and then tomorrow also, and then 2 days off. So they don't have any homework, and they're all playing games with my husband in the other room. So if you hear,
Oh, that's awesome.
you hear stuff
Is
going
it
on in
fall
there,
break?
huh?
Is it fall break?
No, we have parent-teacher conferences, and then the NGA EA weekend. So the teachers conference weekend.
Wow.
Okay.
So it's a fun little break. They're
That
excited
is
in
nice.
there. No homework is really nice.
Right?
They rubbed it in pretty good this week, though. Mom has homework.
Oh,
Has
Yeah,
homework.
I bet.
Like, thanks, guys.
we're technically only using 5 variables. We're not using the socks in this one, right?
Yeah. So you don't have to transfer the information for the socks.
So
So what did you get the p-value as?
0.309.
that's what I got.
Yep.
Yeah, okay.
Okay.
And then number 9, the p-value always goes up when only one group is removed compared to the p-value when all of the 6 samples are included. True or false?
Yeah, that's false. I'm checking it, and it is false.
False.
Mm-hmm.
So you're removing.
Sometimes it goes down.
Sometimes it
Well,
does go
I
down.
was going to say that number's lower anyway, so.
Right. Okay, perfect.
Actually, the number's higher.
The first, the
Oh,
first one you remove,
yeah, actually it
goes
is.
up.
Did I say always makes me nervous?
Yeah. Yeah. Always.
No, I just checked them all.
Sweet.
No.
Oh, you did?
Yeah.
Haha, you're awesome.
You're fast.
Yeah, she's like, they're talking.
So,
I'm just going to check all the data.
You guys have your little chat. Just kidding.
So now we have to remove for number 10, one group at a time to find out which one is the highest possible.
Oh, what is the highest p-value you see when removing only one group?
okay, so what did you put for 9 then?
False.
You put
False.
true?
It's
Oh,
false.
false. Okay.
False. So the highest p-value you see when removing only one group. So you just went through and did all of that?
I did. And it's 0.448.
I don't even know how you did
So
that.
I could go.
It must be easier on Excel to do
It
it.
is. It's way easier. I just deleted them, put it back in, deleted it, put it back in.
Oh, wow.
Yeah.
0.448.
Oh, the minimum. I should have paid more attention. I didn't know I was going to ask for both. Oh, that's annoying. Okay.
Oh, wait, it's asking us for the variance, though.
What?
When all, on 11? Is that what you're
What
asking?
is the smallest variance?
When all 6 samples are used, what is the smallest variance?
4, because 6, they couldn't find a way
It's
to
27.208.
Here. So it's your turn.
What is it?
27.208. Does that?
27.208.
Do you guys see that at the? So it has like the mean.
Yep.
Okay. You guys got the same thing.
Yep.
Yay.
That's for Group C, right?
Yeah.
Hey, hold on. So sorry.
Okay. So Ethan, you're gonna start.
Okay, got it.
So 27.208.
Yes.
That's 4.
That's 2.
And then for 12, did you guys get 53.158?
Yes.
Yes.
53.158.
Yeah. That's right.
I'm Justin.
Oh, I lose a guy.
The test for equal variances is satisfied for these days.
I want to support your.
True.
Is that true?
Yes. Because 53.1858 is not 4 times
It's not
greater.
times
No.
It's not 4 times.
27.208.
Oh, the smallest one.
Yeah.
Check the QQ plot of each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. Let's see.
Let me go back to my QQ plots. Okay, A is normal. B is a little concerning, but still kind of follows the line. C is normal. D is normal. E is somewhat normal. Of course, then I need to. I erased the data for the socks, so.
Hey, Karina, can you do QQ plots on Excel?
I don't know how to.
The QQ plot for B is a little off, but I can show you guys here.
Approximately normal.
It's close. Let me just bring up the information. I just need the info for the socks again. And let me plug that in. Actually, I could probably just go here.
You're like facing this way while we're like right here. And you're stacked.
I can shoot 2 Ethan. I have 2 people.
Oh, God.
Oh, I found it, Karina. On the bottom of the Excel thing, it says QQ plot.
2. 2. 2.
Should we put a QQ plot in?
Yeah.
That'll be good.
Where?
In the thing now.
So
And not just yet, Sweet Pea.
I thought I had to use SPSS.
What time should I get in?
Not. Let me finish here, and then I can help you.
descriptive, whatever it's called in this thing. Quantitative descriptive statistics. Go to very bottom, it says histogram and descriptive to stat. Getting feedback version. But I'm not sure how to enter the information.
And then I get a +1 per.
Quartile?
That doesn't mean I can't next turn. That up.
No, mine just did something funny on me.
Stay this side. Yeah, just stay there. Just stay there.
So we all get troops, and then we're just gonna be like, whoever gets all the troops first will be on.
Do you see that QQ plot?
I don't.
It's on the very bottom.
I'm just pulling that up. So let's see.
Yeah, something's going on with mine.
Mine's just slow, but
Hold on, please type in column E to sort column A from lowest to highest. Oh, I see. We have to do it by each column for Excel.
Once you get out, once you get in.
I don't work in the car.
Did you find the quantitative descriptive statistics?
We need 4 starts.
Okay.
Right?
Alright, Maddie.
okay, let me see. So,
Search once. And
Okay,
then.
whose turn is it?
Okay, let me just go back through here and do this.
No, James. Yeah.
Hmm.
Create a nice
I might be
strong
in
area.
reserve.
Well, it closed my SPSS completely.
Oh, shoot.
oh shoot.
I was trying to go in and I opened the information again to try and copy just the socks and repaste it into what I had done, and everything froze on me. So
Oh, shoot.
Okay, here we go. So normal QQ. Let's see. That one looks. Oh shoot.
Got it.
It looks okay. There's one outlier.
B was the one that concerned me the most.
Which one?
Which was?
B, because nothing was
Okay,
really
let
on
me
the
look at
line.
that.
It was kind of funky.
So they're just gonna like kill me. You know? Because you're not like they're
No, we're not on this one.
and it's a locker.
Or, I know, but it's only the
Are
one.
you done?
Yeah, I don't think B is.
Are you done?
Because
Yeah.
half of those are way under the line.
Not least one character response.
Yeah, that does have a little bit of an S.
Yeah.
That's what I was kind of like. I don't know. That's where I would get concerned on that one there.
Yeah. QQ parts are difficult for me because when they say they're normally distributed, I don't think they are. When they say
Right?
they're not, I think they are.
That's exactly the problem I have. That's why I wanted to look really quick to see about the socks, to see if the socks one was any different.
On B,
You know what though? C. I don't think C is either though. Because there's 4 up at the top that are way under also. Do you see that?
Yeah.
So I thought that it was if you could have a straight line and the plot or each point was in a general direction about the majority of them, because like in the video there were a few on the bottom or the top that weren't exactly in that line.
Yeah.
But I think like B kind of follows that line. I don't.
Show me, can you do a screen share with me, Ruth, and show me the one that you think is
Yeah.
off?
Okay. So this one here, can you see that one?
Yes. That one looks fairly normally distributed.
So we have this one here.
That's true. That one's definitely on.
That one's definitely on. This one was the one that I was a little concerned about. But I hadn't done the socks one yet. So this one, that one's normal. This one's normal. This one has a couple of things, but still tends to follow that same thing. And then this one, except for those two there.
Yeah. Whoa. What was that one in the middle?
Oh, what, this one here? Yeah, I don't know.
That one is not.
It's the detrended normal. So whenever I hit all of the plots, it brings up this one, which we never use the information for because none of them are normal. If you look at them, they're kind of.
And he said don't use that information, the detrended.
Yeah.
Oh, okay.
In his video.
So the only one that would be off would be this one. But you know what? Why don't we check how many
I think like
I
this.
just want,
Yeah,
oh, we're at 20. I'd say we're probably close enough. I mean, with the sample size.
Yeah.
I want to say there was something that I saw, maybe in the, because we use this in our textbook study as well. And it did ask if it was normal.
Yeah. But I'm gonna go back and let me see. Yeah.
Okay. So verify the requirements that have been met. So this is for the same data from the book. And it says the QQ plots of the data for each of the 6 groups separately do not indicate a departure from normality. So the largest standard deviation is not double. Okay, that's just talking about the variant stuff that we did. So but it says that it does not indicate a departure from normality. So if you'd like to confuse those words a little bit more and not just say yes it is and no it isn't, but it sounds like it's saying that that they are normal.
Yeah. I don't think it's a large enough departure, like it was saying.
Okay.
Yeah. I mean, that's what I would have said, but I seem to always get it wrong, so I don't trust myself.
Right?
We're all like, yes, it's
Approximately,
definitely
and
true.
it does say, like Minette said, it says approximately normal.
Yeah.
So it would be true.
Yeah.
So for 15, I put right.
Yes.
Yeah.
Yes, it's always right.
Can we go back through them? I just want to make sure. I'm a little
Yes.
So number 2 is true.
Yes.
4 is B and C.
What
Yeah.
number?
B and C. Can you hear me?
Yes. Yes.
What number did you say?
Number 5. B and C.
So we put C, construct a QQ plot.
Oh, I was on number 4.
Oh, 4.
Sorry. So
B
for
and
4 I
C.
put B and C. Number 5 I put C. 6 is B. 7, 6. 8 is 0.309. And 9 is false.
Wait. Can you go back?
Sure. Which one?
Okay.
Number 8, I put 0.309.
Okay.
And number 9, I put false. 10, I put 0.448. 11, 27.208. 12, 53.158. 13 true, 14 true, 15 right. That sounds good?
Yep.
Okay.
Yep.
Are you ready?
Ready.
All right. Ready or not?
Woo!
Yes?
Woohoo!
Oh, good. Yay.
We rock.
That is awesome.
Yay.
Sweet. Good luck.
Awesome.
Good luck on the test, ladies.
That really
Yes, you too.
Thank you.
Right? Okay, so on
Now I'm kind of worried because
Thursday-
I don't have.
What were we saying?
Oh, I was just going to say I'm kind of worried for the test though because I don't have Karina to do Excel for me for those easy ones. Maybe I need to figure it out.
Maybe go back and check on how to do the Excel stuff.
Yeah, that's what I'm going to have to do. So Thursday, does 5:10? Does that work?
That should work. That should
I
work.
don't get off of work until 5, well, technically 5 o'clock. I might be a little bit late.
Okay.
Okay?
That's
Karina, is 5:15 or 5:20? Is that pushing it too much for you?
I just have to leave by 6 p.m. Mountain Standard Time.
Well, you know what we can do is why don't we go ahead and meet at 5:10? We can start all of the information and then make sure that we spend some extra time with Minette after to make sure that she's caught up with us once Karina leaves.
That sounds
Is that
awesome.
all right, Minette?
That's perfect. Thank you so much.
Okay.
Okay.
Yay!
And I'll kind of be pushing it at 5:10. It may be about 5:15 by the time I get all the invites done,
Okay.
Okay.
if that's okay.
Yeah.
All right. Okay, ladies.
Will that work? Okay.
Yeah.
Sounds good. See you Thursday.
Okay, thank you.